A warm good afternoon to one and all present over here. We welcome you all to the Department of ECE organizing 5 days faculty development program on Internet of Things for emerging technical applications. Here comes Selvan A. Jnanaprakash of 3rd year ECE department to give the introduction about our chief guest.
Good afternoon to one and all. Our Honorable Chief Guest, Mr. S. Tamil Selvan, ME, PhD, AP, ECE, IoT Lab in charge, Bannariamman Institution of Technology, E-Road. He has completed his bachelor degree in Electronics and Communication Engineering and completed his master in VLSI Design and now pursuing PhD in IoT. He has 5 years of experience in embedded and IoT and has 13 years experience of teaching experience. He is expert in Internet of Things, cloud embedded device, sensor, gateway, hands-on experience in IoT cloud like Adafruit, Cloud, Azure, IoT, and Cloud and AWS. He is involved in end-to-end design and development of IoT solutions for various sectors like industry automation, transportation, environmental, and infrastructure. He delivered motivational speech on Internet of Things in various places and also trained more than 1,000 students in embedded and IoT technologies. Being an Internet of Things expert, he is popularly known as IoT Embeller and currently works as IoT Lab in charge. Under his training and mentoring, 60 IoT Lab students won top 3 position and received cash award of 7,58,250 in 20 plus national level project design contest. A multi-talented person with more professional skill which inspired us all to admire all of his works. A remarkable personality whose dynamic impact resonates deeply with us all. His dedication and exceptional talents have left a lasting impression, earning a special place in our heart. We are honorable to have him with us today. He is desirable for our beloved chief guest.
Thank you, Jnana Prakash, for the wonderful introduction. Next session starts with our chief guest. I welcome you, sir.
Thank you, Mom. Thank you for your wonderful welcoming. A very good afternoon, professors. I hope my voice is audible and my screen is visible to you. Is anyone confirm? Is my voice audible and my screen is visible?
Sir, yes, sir. It's visible and audio.
Thank you, sir. Thank you so much.
Sir, but full screen, not in full screen, sir.
Yes, sir. I'll go full screen.
Okay.
So, I think now it will be better.
Yes, sir. Visible, sir.
Thank you. Okay, good afternoon, everyone. This is Senthil. So, here we will start with the real-time implementation of IoT-based agriculture system. So, I'm thinking that you'll be well known about the IoT and you heard about the terms and how to use with the components. With that idea, I'm going to present my view. And if at any point of time, if you are not able to understand or if the things are new, you may ask me to repeat. Okay, I'll give you. And my aim is to have a real-time implementation. So right now I'm having a demo module with me, and with that I'm going to interact with you all. Okay. So suppose if you are interested in parallelly, you can able to create a cloud account in the website what I'm suggesting, and parallelly you can work with me so that you can visualize the things which I'm going to share from my place. Okay, so this is how it works, and this is what my plan is for it. And first of all, Internet of Things in the sense in a fast forward view, I will just go through what is what in the for the first few slides, and later on we will enter into the smart agriculture systems. Okay, so the professors, the Internet of Things has two important words. One is Internet, and another one is Things. Where the Internet is a connection of computers in worldwide, and the things are nothing but the thing what we can able to see through our eyes. For example, if I see you, you are a thing, and if you can see me, and it's me as a thing. So likewise, things are anything. Okay, even the walls, chats, or vehicles, buildings, devices, whatever we see through our eyes, it will be called as a thing. Okay, and the majority of the things are not able to communicate with us because it is an immovable object. Okay, so in that situation, we will be embedding some sensors, software, and electronic circuit devices so that those immovable or non-electrical things can be interact with our devices or the controllers. So we will be connecting all these things to the internet in order to exchange the useful information. In other point of view, we can say the Internet of Things will be called as a interrelated computing devices, where it will be assigned with some unique user IDs. Say, for example, we will be having our mobile phone with a unique mobile number, and we will be having an Aadhaar number. So similarly, a device which will be sharing anything in the internet will have its own ID. So that is called as a unique identifier. So with that identification only, we will be understanding which particular device will be communicating. The best example is our Gmail network. So we all have our own Gmail username and a password. So with that username and a password, anywhere in the world, if we are having some internet connectivity, we can able to see our inbox messages, and we can communicate with anyone else. But suppose if we doesn't have an unique ID, then we may be having a chance of getting the other's mail. But it is not occurring because we have provided with a unique identification via the useful through the internet. So this is a simple definition of any IoT. Next is the list of things which can be used as a thing in IoT are given here. So you can find all the day-to-day life things can be listed here. Your cooker, your light, your refrigerator, your trolley, your aeroplane, your car, whatever we are having in our life will be used as a thing. Say, for example, in olden days, suppose if you are booking one flight, and if the flight time is by 4 o'clock in the early morning, then suppose we are supposed to book a cab at by night 2 p.m. to reach the airport. So suppose you think this situation, if the flight was delayed by 4 hours, instead of 4 o'clock was starting by 8 o'clock in the morning. So unnecessarily we'll be waking up by the midnight by 12 o'clock. We'll be booking the cab at the 2 o'clock. So this is unwanted thing. But if these things are connected to the internet, if it is IoT based system, then what it will do in the sense the delay of the flight will be earlier notified to you, and the system clock will be automatically adjusted, and the alarm clock will be automatically adjusted. Instead of 2 o'clock, it will be adjusted to 4 o'clock or 6 o'clock according to the flight timing. So it is an automation. So you can have a peaceful deep sleep at the night. So similarly, you can automate any one of the parameters in your code. So that is what the advantages of using Internet of Things in real-time life. So these are all the other examples. A person with an implant heart monitor. Nowadays, health issues are more, so we'll be having individual health monitoring devices for each person, and even we can implant those sensors into the farm animals so that we can able to track those animals in the agriculture systems. And also, you can have an automobile alert, and you can any natural or persons can be assigned to one particular IP. With that, we can able to track them. So altogether, if you understand this particular slide, then IoT is nothing. Okay. So IoT has three major parts. First one will be IoT device, and second one will be your cloud, and third one will be your remote device. Okay. And many of the students will be doing, they will be saying that the project is IoT without internet. Okay. But there is a mild difference between the IoT and an embedded project. Okay. So first of all, if you see through this first part, it is an IoT device where it will have a controller, sensors, and an actuator. Three parts will be there. In other terms, we can call it as IoT node. In this IoT node, there is a controller, microcontroller, which will repeatedly do a task. Say, for example, traffic light controller. We will be having a traffic light controller in one place so that it will automatically turn on the green light for 30 seconds, red light for 60 seconds, and yellow light for 5 seconds, likewise. So continuously it is doing the job. So there you have an actuator which will actuating your three different lights for a particular period of time repeatedly. So this is a perfect example of an embedded system. It is not the IoT project. So where comes the IoT in the sense? Say for example, I am here, and if I can able to see the traffic light status from any other part of the location, then it will be an IoT. So how we can do it in the sense, we have to connect that device to the internet at first. We have to provide an internet service to that device, and then that device will be taking the data into the cloud. So cloud is nothing but, as I told earlier, it's like your Gmail account, where there will be a server, and there is an IP address or website address. In that, you have to create your own account. So on behalf of the IoT device, you have to create, because the device cannot create. So you will be provided with a username and a password. In addition, you will be given with an API key. So using these three parameters, your device will be sending those data into the cloud. Okay, where there is a database in the cloud, and that database will be written with your data. And whenever you want to go for an analysis, say for example, if there is any ambulances coming to the controller, immediately we need to turn the signal green on. So what we can do is, from the remote location itself, we can analyze the parameters, and if we identify that the ambulance is coming, immediately we can change that particular signal as into green, that particular path signal into green. So that is nothing but a remote analysis. So we'll be doing analysis by using our website or by using our mobile phone apps and all. And after that, we will be posting those data in the cloud itself. Also, it will be sent as a command to the IoT devices. So by that, we can automate our traffic light controller using IoT. So this is all about the IoT part. So three important parts: IoT node, cloud, and a remote system. So here another one example shows how does your system is connected with the cloud. Okay, so here you have many number of devices. So worldwide, billions of devices will be connected like this. In order to provide an internet connectivity, we are using a gateway. So gateway just for giving your internet service, and also for channelizing your data. Okay, so for that only we are using gateway. Via the gateway, we can able to reach the data into the cloud platform. So we use three things: sensors, actuator, and a controller at the node. And we will be having two communications and connectivity protocols in order to take our data into the cloud. So for example, first one is connectivity protocol, and second one is a communication protocol. So protocol is a set of rules. We'll be having an LoRa, Wi-Fi, Bluetooth, Zigbee kind of things to give just an internet connectivity for your IoT device. It is not providing any data service. It will just connect with the internet. Okay. Next, we'll be using a communication protocol. Here only your data will be channelized. So whatever the parameters you are measuring up to one end will be processed, and it will be in the format of MQTT or AMQ or COAP or HTTP format. It will be reaching the cloud. Okay, and at last your data will be residing in the cloud platform. And by using different apps, we can able to visualize those parameters, and we can able to send a control signal. So visualizing and controlling any part of the world from any part of the world with the help of internet is called Internet of Things. So here are some of the connectivity protocols. For short range, we can use Bluetooth. For a local area network, we can use Wi-Fi or LAN. Or wide area network, we can go with LoRa. So kind of depending upon our application and the cost of the project, we can able to go with the different connectivity protocols. And there is a very important quote called everything that can be automated and will be automated. Okay, so you cannot say that these things will not be automated in IoT. Whatever you thought can be easily automated by using Internet of Things. So that's the best of it. So in simple, we can say anytime, any device, anyone, or any service, or any business network, anywhere or any location, the things can be automated, provided you have to give an internet connectivity. And this is an evolution where the first 3 stages will be embedded part, where you will be just connecting the IoT devices, and you will be connecting the data. By collecting the data, you can able to get the interact with you can interact with your cloud. First part, and the later part of the IoT is complex analytics, where you will be analyzing the data and you have to come to a unique solution. Okay, based on that solution, you have to act on something. So that is what the evolution states. So where do we have these applications of IoT in the sense? See, all part of our life. Okay, so in this slide, you can see everywhere the IoT can be applied. So I'm much more interested in agriculture point of view. So here is the one particular slide, so which shows how your agriculture system can be automated. Say, for example, you are having a very big land yard, and you want to automate the irrigation system, and you want to know the weather parameters in the sense, then we can go and implement our IoT system. So what are the parameters that we can automate is listed here. So the data which is coming from the sensors will be temperature and humidity sensor, soil moisture sensor, intrusion detection. I have taken for this particular application. Okay, and via this sensors, your data will be reaching to the IoT controller. So normal controller and IoT controller will have a one difference. So it is like a button phone and a touch phone concept. Okay, in button phone you don't have the internet connectivity, and in touch phone mostly we can have an internet facility. So similarly, your Arduino will be used most widely for normal embedded projects. Okay, but whereas in the case of IoT, we'll be using special devices called Raspberry Pi or an ESP system or an STM32 kind of microcontrollers. So those controllers will be taking the data from your sensors and it will be processing here. And afterwards, it will come to a conclusion whether to turn on the motor or not. Okay, and also the status of each particular sensor and also the motor will be displayed in the LED or by using some LCD display. And for all these things, we need a power supply. Suppose if the plant is in the remote location, then definitely we need to go for battery operated device or something like a solar cell. And this is all about the connectivity. So here I have used an Arduino along with the Wi-Fi module. So as I said before, the Arduino is just a PCB module where you don't have the internet connectivity, but the sensor data can be fetched easily by using this Arduino device. And the Wi-Fi module will be used for communicating with your hotspot. Okay, so here in this case, I'm using my mobile phone hotspot as my internet service provider, like a gateway. And by using my mobile phone hotspot username and password, I can able to send my data to the cloud devices. Okay, and here I can able to visualize my status in the LCD screen. So this is not the IoT controller what I have used now. So in the previous slide, there are two devices used. One will be Arduino, the other will be a Wi-Fi module. But instead, this particular ESP device will have both. Okay, so it has a Wi-Fi connectivity and also an Arduino board inside. Okay, so it will be called as a Node MCU module or ESP8266 device. Here are the GPIO pins, general purpose input output pins. So we have many pins for communicating with our sensors and to the actuators. And here we have TX and RX pins for I2C connections, and also MOSI MISO pins for SPIO connections. So SPI connectivity devices. So we can able to easily communicate with all the sensors as like in the Arduino module. So this is how I have given the connections. So I have converted the 230 voltage into 5 voltage by using a regulator IC, and I have supplied to the node MCU module. In two ways I can able to give the supply. So here at the bottom you can see there is a V pin and a ground pin. By using this I can get the power from my battery, or by using this Type-C USB cable I can power it on. And the next one I have used the DST level temperature sensor. Of course, this is most practically used and cheapened test sensor. So this sensor will give you the temperature as well as humidity parameter. The next sensor will be a soil moisture sensor. This will give you whether the soil has any liquidity or not. Okay, if there is any wetness, it will be identified. And there is a PIR sensor which will detect the motion. So instead, you can use an ultrasonic sensor also. So the job of this sensor is to detect if there is any movement in the land yard. Okay, say for example, if any elephants are continuously disturbing your agricultural system, then the path of the elephant we can able to place the sensor and we can notify if there is any movement of animals or any other objects. Okay, it can detect anything. And next one is a OLED display where you can see your values and things. Next one is a motor. Via the relay, we can able to control the motor. So this is called actuation, right? So these are all sensor part. This is the actuator part. So since the motor is running with 230 voltage power supply, we cannot directly connect with our microcontroller. So our microcontroller output will be 0 to 5 voltage, or sometimes 0 to 3.3 voltage only. If it is on condition, it will generate 3.3 voltage. If it is off condition, it will generate a 0 voltage. So by using that, we cannot operate an AC device that too operated with a very high voltage called 230. So or 440. So what we can do is we can go with a relay module. So this relay module will receive the low voltage DC signal, that is 0 voltage or 3.3 voltage, and based upon our input, it will turn on the motor with the 230 voltage. So here at these three pins, we can give the 230 voltage directly. On the other hand, this side will be having an pins to connect with our microcontroller. So since it is a magnetic device, it will not allow the current to flow from 230 voltage AC to the microcontroller 5 voltage DC. So it will restrict the current flow between these two. So your microcontroller will be more safer. So this is the list of components. So ESP8266, air temperature module, soil moisture, temperature device, LDR. Sometimes we can predict whether there is a sunlight or not. So for example, if you want to turn on any kind of light in the sense, then we can use LDR sensor where it will detect the lighting, and if there is an options of lighting, you can automatically turn on your light. And the pH sensor will be used for measuring the soil NPK levels. Okay, sorry, soil pH level, and we also can use NPK sensor for calculating the better composition of N, P, and K values. Based on that, we can go for suggesting some fertilizers into the field. And we can use a motor controller module and water level indicator also. So water level indicator here also we can use ultrasonic based IoT microcontroller. So these are the list. Suppose if you want to give an alert to your animals, so by making some sound, if you want to alert anyone, then you can use buzzer or speaker, and also vibration sensor you can use. So nowadays, if you are placing that vibration sensor on the floor, easily you can able to detect the movement of the animals. And fire sensors also you can able to use for detecting the forest fire. And the GSM GPS is most widely suggested for the remote locations. Suppose if your land is located too far away from your home, then no way that you can give internet connectivity. Either by using a LoRa or by using GSM module, we can able to send these data. And you can use an SD card module also. So it will detect all the sensor details and it will store in the form of CSV file in your SD card. So whenever it has a provision to send information via internet, or whenever it detects an internet connectivity, it will send you those data. So that also possible. So this is a ultrasonic sensor, as I have told before, and the list of sensors what I have used in my project, and that overall cost is given here, around 20,000 is coming, and this is how my student has implemented in his lab. So he has developed this project in my laboratory, and he has implemented in his field, and right now it is working fine. So it will automatically turn on the motor based upon the information he is sharing through his mobile phone. So he has developed a mobile app. So from that app, he can able to send the turn on off message. So he used an GSM module here to fetch the data from the lanyard. And he also has developed an website, so which will display the values in a graphical format. So this is how a database will be looking like. So we have developed our own PHP code, and with that we have logged all those data, whatever we detected. So with this, I'm going to wind up my PPT session and move on to the practical session. After this, if you have any queries, you may ask. Any queries so far? As I'm moving on to the hands-on session, where I'll be having all the controllers and sensors to send the information to the cloud. Right now, I'm doing it from my location, and you can able to visualize. Any doubts? Okay, thank you. So I'll proceed with the coding part. Okay, now, so it is nothing but an Arduino IDE. So this software is free, open source software. You can download it from the Google itself. So just type like an Arduino IDE download. You'll be given with the two options, a legacy version and a normal version. So you have to install this legacy version 1.8.19. Okay, so this will be most suitable for all the microcontrollers. So that's why we preferred this one for our students. So you may also be suggesting the same to your students. So first one, we have to go to file and create a new programming. Okay, so this is called as a sketch. No sketch programming we will be calling it as, but it is more widely like a C programming only. Okay, so more similar to that of your C programming, and also your files, header files, everything will be like a Arduino, sorry, C and C++ code only. So as like in C programming, first few lines will be your library packages. So here also we are using many sensors. So each sensor may have its own unique format of data set transmission. So what we can do is we have to decode the data. So we know that the sensor data will be always from 0 to 5 voltage or 0 to 3.3 voltage. So that data we cannot able to send it to the cloud asset because it is not like an temperature or the humidity, because your data is in voltage. So in order to convert that voltage into a proper temperature or the humidity value, we have to go for predefined library packages. If you want, you can write your own, but there are some packages available in the GitHub. Okay, so GitHub is a quick source where you can find all these code and library packages. So say, for example, I have used an ESP device here. So DHT-ESP.h is the library I have specifically used it for this particular application. So for this, I can go to Google and I can search for this particular library. So most likely it will take me to the GitHub source or Adafruit website where I will be having this library. Okay, and you please ensure that DHT has many varieties. DHT sensor 11, DHT 22, 33. Likewise, we have varieties of DHT 11 sensor, and also this DHT will be having its own library. So, for example, the keyword which is used in each library is different. So, uppercase DHT, lowercase DHT, DHT, ESP are the different libraries that you can find across your net. So, what you have to do is please choose the right library and include those libraries by using the method called tools sketch input library and manage library or add zip library. So there are difference between this manage library and the add zip library. By using this manage library, we can able to install, but there will be some problem. Suppose if you want to change the library, then it will be written in the C drive itself. So you cannot change or delete that particular library. Sometimes it may malfunction your entire programming. So my suggestion is to go with the add zip library. So by using this option, we can download the libraries in the offline, and just by selecting that particular location of the library, we can able to install it. So this is the easy way. So if you are doing like this, suppose if in a situation if you want to change a library, immediately we can delete that particular part. And next one is most important thing, that you have to choose the right board. Earlier, the board manager doesn't have the ESP devices. Now I have installed this board, so you'll be seeing this one. But in the case of your normal installation, only Arduino boards will be available. Arduino, Arduino Nano kind of microcontrollers alone will be used. So if you do want to have an ESP device, say for example, you are having some ESP8266 Wi-Fi device in the sense, this particular library works only with the board ESP8266. So for that, you have to install the board. What you can do is you just go and search in the Google like ESP8266 board installation. So if you search like that, then you'll be given with one website called Random Nerds Tutorial. So this is the best ever website for all the IoT beginners. If you are going to start a new IoT project, please go into this particular website. Step-by-step procedure with video and a screenshot will be given here. And also you can find all the latest IoT controllers will be listed here. You can use ESP32, industrial standard, ESP8266, ESP32 CAM, Raspberry Pi, or even Arduino, Raspberry Pi Pico, Microton. So MicroPython code, so many things will be available. Okay, so category wise. Okay, and in this they will be giving you the video as well as the step-by-step screenshot how to include this particular board. They have given you step-by-step guiding. Okay, so again I'm telling
Sir, Tamil sir. Sir, do you hear me, sir? Tamil sir.
Hello. So is my voice audible now?
Yes, sir, it's audible, sir.
Sorry, sir. I didn't see that my internet connectivity was disturbed.
Okay, sir. Thank you, sir.
So I think I have left off with the pins, right? Sir? Up to which part?
So simulation part after installing ESP8266.
Oh, I'm sorry. Okay. So now we have to go with some board selection and then library management. So if you are manually downloading the library, please go to Sketch and click on Include Library. Then select Add Zip Library. Using this, you can able to install the library manually. Okay. By installing manually, you will be having an advantage that you can easily change the library whenever you want. You can easily delete and you can change. And another one important thing is the board. Okay, so usually we'll be having a board manager, and there you can find all the Arduino and the other boards available. Most widely, this ESP will not be come in built, so you have to install it separately. So for this, what you can do is you just go into the Google and search for ESP8266 board install. Okay, so it will take you to the website called Random Nuts Tutorial. So this is the best website I'll be telling you for beginners of IoT, and for the advanced programming also you can use this one. So ESP8266, ESP32, ESP CAM, these are all the controllers available. So each controller has its own programming and how to do each and every step will be given as a screenshot. And also the video demonstration video is given in this particular website. This is the best one. And here you can find how to install this board. So there is a video and also your step-by-step screenshot will be given here. Okay, so by using this you can install the board. So first of all, you have to go and choose the board and ESP8266. In this board also we will be having many versions. Okay, so 2.5.0 is the best one for all your IoT projects. So here there are two NodeMCU devices will be given. One will be NodeMCU 0.9, another one will be the NodeMCU 1.0. So you have to use NodeMCU 1.0 12E module for the best performance. Okay, and here we have the list of libraries like C coding. You'll be having an C coding only. So that is ESP, DHT, ESP, adapted MQTT client, adapted MQTT kind of library files. Okay. So in order to install these libraries, you please select this library and then go to Google and download it from the GitHub source. Okay. So here you have a GitHub source for providing your sensor libraries. Most widely, adaptive libraries were preferred for our IoT applications.
Sir, excuse me, sir. Kindly share the screen, sir.
Since I got joined, okay, forgot.
Yes, sir. It is visible. Thank you, sir.
So this is the Adafruit website. In that Adafruit GitHub, in the GitHub account, we have Adafruit's sensor libraries were listed. So these are all the best libraries that you can use for IoT projects. Okay. And the next one is a sensor pin, where I have used A0 is the sensor pin for analog sensor. And I can use D1, D2, D7 up to D6 pin. I have used for some sensor input. So I have used DST sensor for in the D1 pin, and the LED for my output as D2 pin, and the motor pin will be connected with the D7. And I have connected my ultrasonic sensors trigger and echo pin with the D5 and the D5 pin. So if you see this particular controller, you have only one analog sensor. In the case of Arduino, you'll be having 6 analog ports to connect with it. But here you have n number of digital pins connectivity. So I have used all the pins here. Next one is the variable I, which counts for every 5 seconds. And I have used my mobile phone hotspot for providing the internet connectivity. So this is my mobile phone username, hotspot username, and the password. So similarly, if you are using college network, your username and a password will be given here. And the next one is the cloud parameter. So here I have used the Adafruit cloud. So many cloud service providers were available for the IoT project. So there is no need to pay for anyone. You can easily get free clouds. Okay. So one best cloud I ever find is this Adafruit website, where the dashboard and the feed facilities were, and the GUI facilities were very good, okay, compared to all other clouds. But since they were free, they'll be restricting you with a few points. What are the things in the sense? The number of hits, the number of data that you can able to send in a one particular minute of time will be limited. So in this cloud, so there are 60 data that you can able to send. Say for example, 60 times you can send, 30 times you can send the temperature data. Suppose if you are sending temperature and humidity data in the sense, 15 each you can able to send. 15 temperature data, 15 humidity data you can send. Suppose if you are sending 10 different sensor data in the sense, then maximum of 3 times in a minute you can able to send the data. Suppose if you are sending 50 data in a minute in the sense, first 30 data will be stored in the database, and the remaining 20 data will be ignored for the first minute. Okay, so within 10 seconds also you can send 30 data, not an issue. But after that you cannot send not even a single data for until there is a 60 seconds. So in the next minute it will start accepting the next 60 data. So like this, these clouds will be having its own restrictions. So how do you create an account in this website in the sense? Please go to adafruit.com. So you'll be given with the Adafruit web. You'll be directed to the Adafruit website. So most widely it will go to shops by default. So this is the default website, adafruit.com. So here at the top right corner, you will be having an IO. So where you can communicate with your devices, okay, input output devices. So if you are clicking onto the IO, it will be converted as io.adafruit.com. Okay. And as like a Gmail account, you can able to create your own account in this particular website. So by using your Gmail and by a new password, you can create an account in this particular website. Okay. So after creating this, you will be given with one dashboard. So here there are devices, feeds, and dashboards available. Okay. So the number of feeds will be limited here. Of course, you can use 10 feeds at a time, and the dashboards are limited to 5. The dashboard is the one which is nothing but a collection of your feeds. Okay, feed is nothing but your sensor values. Okay, you'll be given with each sensor data in each feed, each feeds. Okay, and say for example 5 feeds if you are configuring to one single dashboard, then it will be called as a one project. Okay. Even you can connect many feeds in one particular dashboard. So these are the list of feeds I have created. So humidity values, intrusion values, motor devices, soil moisture, temperature, fan switch, spy cam. Even the Raspberry Pi camera image can be displayed in this particular cloud. Okay, that too is a free, and you can have a switch for controlling your motor parameters. And you can create some groups also. For example, first 5 feeds I will be connecting with one particular group, that is this particular FDP group, in this, I can configure like group also. Next one is the dashboard. So this is where my all sensor data will be shown. Okay. So in this dashboard, we can able to use or we can able to edit the layout. Okay, so here is the option for editing the layout. Even you can able to include new feeds. Okay, so for example, if you are using a new device, by clicking into this, we can able to create a new device. Okay, so since the time restriction, I'm just created a few devices earlier, and you can continue with this. And inside which you can create new blocks. Say, for example, I have created 2 switches and 1 temperature module. So similarly, if you want to add more, then you can click on to this create new block, and you can create your own model. And each model will be communicating with the, one particular feed. Okay, so this particular motor switch will be connected with the motor switch. See, there is a feed I already created as a motor switch, and this motor switch was connected with this switch. So if I'm turning on the switch, it will be reflected in this feed, and this feed will be read by using this code. Okay, and here I have a username and a password. As I said before, like Gmail account, you will be having a username and a key. So this username and a key, you can find it here. So there is a key symbol. By clicking into it, you can use you can find a username and a activation key. So these 2 parameters you have to put it in the code so that your device will be communicating with the cloud easily. Okay. Suppose if you by mistake, if you are using my key, in the sense my dashboard will be feeded with your data. Okay. So in that situation, if I do want to secure my cloud, I can regenerate my key. Okay, by clicking into this, I can able to get a new key so that I can receive my data alone. Okay, so likewise, there is a security feature available in this particular website. And next one is my coding part. Okay, so here I have used Bharath MPPT library. So this device will be acting like my MPPT client. Okay, so I'll be sending and receiving the data by using this client ID. So publish in the sense sending the data from your controller. Okay, so I'll be used to the feed name called the temperature for publishing my temperature data. So this uppercase temp will be used inside my program, and this feed temperature will be matching with my cloud parameter. So please be careful that your temperature, this feed name and the feed name which is available in this website are matching. Okay, suppose if this temperature is not matched with this one, in the sense it won't publish your data. Okay, and the humidity, I have created another one feed. So here you can find humidity. So likewise, I have created all the feed whichever I'm using in the code: soil moisture, motor switch, infusion, everything. And for each feed, I have created an internal variable which will be used in my programming. So here, motor switch is the name which I'm using in the cloud, and the switch is the name which I'm using inside my programming. And this is the setup portion. So setup portion will be run only once. So here you have DHT sensor pin for initializing your DHT sensor, and the LED, I'll be using this LED as an output device. So I have to declare this pin node as the output because it is a GPIO output pin. So I can use pin mode as a keyword. Okay, so if I mention it as a pin input, it will be act like a sensor pin. If I'm mentioning it as an output, it will act like an actuator pin. Okay, so here LED is actuated, or it will be turned off at the initial stage. So if I want to turn it off or on, I have to use the keyword called digital read and write. So here I have displayed the status of the motor in the serial monitor via the serial printer and keyword. And these are all the code which will be used for connecting with my internet, okay, with my hotspot. So I have used my username and a password. I already configured. So I have connected my device to the Wi-Fi hotspot by using this Wi-Fi begin library package. Okay. Next one, I will be checking whether the connectivity is established perfectly or not. If not, I have to print like ... meaning that it is not connected with any particular internet services. And if suppose this condition is failed, meaning if it is connected perfectly, it will come out and it will display like it is Wi-Fi is connected, and as I said before, each device will be given with one unique ID. So here this unique ID will be IP address, so that will be displayed. Okay, so that will be displayed. Okay, here. So the name of the IP will be Wi-Fi local IP. And next one is subscribing. So since it is an actuation device, I'll be subscribing to the feed called switch. Okay. So from this switch, the data comes from the internet, that is Adafruit Cloud. So that Adafruit Cloud is also provided with an app, best app. It's a user-friendly app which is available in the Google Play Store. So that you can receive, and then based on this parameter, you can turn on off the motors. Okay. So this is a loop programming inside which I'm going to have a MPPT connectivity. So I'll be checking whether the MPPT is connected or not. This is the best protocol for communicating all the IoT devices. So what I'm doing is I'm just ensuring that MPPT is established or not. If not, I'll be having a program here, coding here, which will check periodically whether this MPPT is connected or not. Okay. Suppose if the MPPT is not connected, it will retry every 5 seconds. Okay. So this is a delay of 5,000 results. It is a 5-second waiting. So every 5 second once, it will repeatedly trying, and every 15 times, that is 15 seconds, it will be resetting the Wi-Fi configuration. Suppose if it is failed to connect with the internet. So this is all about MPPT connectivity. And next one is I'll be going to the sensor part. So I'm reading that sensor data by using the keyword called dhp.getCommunity. As I said before, there is a library package inbuilt available. So if you see the sensor data raw format, it will be like a 0.75 voltage. But in order to convert it into a proper humidity value and the temperature value, you have to use the predefined functions dhp.getHumidity in the H parameter and dhp.getTemperature in the P parameter. So by using these two, I can able to save my temperature and humidity data both in H and T variables. So this is floating point variable, so I can measure it in fractions. And I'll be mentioning in the serial monitor that my data is sent to the cloud. Okay, for that I'm just printing once for my verification, and I'm using and soil moisture percentage also, and analog sensor values also. Okay, so by using this analog read function, I can able to read the soil moisture sensor values, and that will be stored in the analog parameter. And the soil moisture percentage, I'm calculating it here. Then that parameter will also be sent to the cloud. Okay, so like this, you can able to hard code your sensor within the program itself, or you can use the predefined functions which is available in the library packages. Both will be allowed. The next one is my ultrasonic sensor details. So I have used ultrasonic sensor for intrusion detection. So ultrasonic has to be triggered, and it has to be received that echo signal by using trigger and echo pin. So it is like a bat sending and receiving the signal. So I'll be using that hard code for converting that received signal into a centimeter kind of values. So the distance will be measured in terms of few centimeters to meters. Okay, up to 1 meter it will detect. So I'll be converting the sound into a distance by using the formula. Duration is equal to, distance is equal to duration into 0.34, the speed of your sound, and divided by 2, because it is sending and receiving a signal. So I'll be using this formula to convert my received signal into a distance signal. And next one is my publishing of data. So here I have my temperature and humidity data, so to be published. So for that, what I'm doing is I'm just using the keyword called temp.publish. Okay, so temp.publish is the keyword which will send your temperature data into the cloud, and humidity.publish is the keyword which will send the humidity parameter. So you can see that the HUM, the hum, is nothing but the variable which we have created as a client, MPPT client in our programming. So at the top, I have shown you, right? So here you have the hum and the H and all. By using this keyword only, we are mapping the temperature value into the feed variable called temperature. and also the humidity. So likewise, we can able to easily publish by using these two keywords. And next one is uploading the inclusion parameters. So every 3 seconds once, I'm uploading this temperature and humidity parameter because, as I said before, there is a restriction with the number of hits per minute. Okay, so we'll be having a problem with the number of data. So I'm restricting the data by using the if condition. Suppose I value is 15 seconds in the sense, I have to stop sending my temperature and humidity data. Or I can set like once in every 15 seconds, I will be sending my one temperature data and one humidity data. So like this also I can able to program. Okay, so here is the hard coding where I'm trying to find out how many number of seconds were passed. Okay, so here I have used a delay, so delay of 5 seconds. 5 seconds. So I'll be counting this I value as 1 by 1. Okay, for every time it will be incremented by 1. Once if it is reaching 3, meaning 15 seconds, it will send our temperature and humidity value and it will reset the value of 5. Meaning every 15 seconds once it will be reset. Okay. So by using your control manager and a device, control panel, you can go to device manager and choose for the port in which your controller is connected. So this is the controller chip ID. CP21X is the library package or the board library which will be installed here. So it will be connected with my COM port 5. So I have to choose the right board ESPS66 Node MC 1.6.1.0 12E module and COM port will be 5. So sometimes you may get more than one COM port also. Okay, next one, I'm sending the intrusion data. So by using publish keyword, so intrusion publish and the moisture values also I'm publishing it to the cloud. And next one is Adafruit subscription. So where I will be connecting my broker. Okay, so here I'm going to subscribe my switch signal. Okay, so subscription is nothing but a switch. More than one parameter also you can subscribe at a time. So here, if you are subscribing to more than one parameter, you have to mention which particular sensor you are interested in, which particular controller pin that you are interested in. So if I'm controlling 2 fans and 1 light in the sense, I have to mention the name correctly. Okay, so here I have used the switch is the name for controlling my motor pin. So I have subscribed this one. So now I'm checking whether this switch has received on signal from the cloud or off signal from the cloud. For that I'm reading the character. What is the last character that was sent from the cloud? Okay, so the last character is nothing but my switch. So I'll be receiving that character as an on and off. Okay, so I'll be comparing this one with my if condition. Okay, so suppose if I'm receiving on condition in the sense, here I'll be getting on condition. I'll be comparing with the on keyword. So if both are matches, then I'll be turning on my LED, meaning I'll be turning on my motor. So here I have used it in a reverse manner. Why? Because I have connected with the relay. So relay is a reverse operating device where if you turn on, it will be turned off actually, because we have to give a reverse input. So if you want to turn on your motor, you have to send a low signal to the relay. So the vice versa, motor will be on, turned on. Okay, so if you want to turn on, you have to give reverse signal to the relay. That is why I have mentioned it as a motor pin low. Suppose if you want to turn off the motor, the actual signal received was off. I'll be ensuring with the if condition, and I'll be sending the high signal to the relay. So meaning my motor will be turned off. And based upon my soil moisture parameter also, I can set whether my motor to be on or turned on or turned off. So I will be sending one signal called moisture sensor. So if the moisture percentage is less than 10, meaning if the ground is wet, or so if the ground is dry, more dry in the sense less than 10%, I will be turning on the motor. So I'll also display the status in the field monitor that motor is running. If the moisture parameter is greater than 40, meaning if the ground is wet, and I'll be turning off the motor. And also this particular status will be displayed in the website as well as in your serial monitor. Okay, so this is all about the code. And here in the cloud Adafruit website, you can see my data are coming. Okay, so see there are changes happened. So 2 minutes ago, I just turned on the motor switch. Suppose if I'm turning on and off, so it will be immediately reflected. See, once if I refresh, you can able to visualize. Here, so less than a minute ago. So what and all the changes that we have done, you can see by clicking into the feed. So I have clicked the feed. Now you can see how many times that I have turned on, turned off, everything. And suppose if my humidity data or temperature data is shared, at what time, from which location it is shared. So it will be mentioned here. Okay. So since I have removed the sensor, it is showing like NAN. So NAN is nothing but not a number, meaning just now, just before the session starts, I have connected. By misplacing the sensor, I just had a problem with the USB device right now. So that's why it is not uploading. But you can see all the data here. Okay, so that is what the meaning for the feed is. Soil moisture, I have received the data. See, soil moisture sensor data is rightly received. Okay, so likewise, you can send and receive all the data by using this Adafruit Cloud. So this GUI is free for all. Okay, that is no need to pay. So this better GUI dashboard and the number of feed 10 will be free for us to use. Similarly, we have a Kinsley Cloud, Fire-based cloud to use with. So if you are beginner, you can start from any one of these kind of clouds, and later on you can create your own PHP code to create an user-friendly website and to display all your sensor data. So it's all about the IoT implementation in agriculture system. What I have, what I wish to share with you all. So what we have seen is a very minimum level of IoT concept. So in future, you have to learn a lot by using these references. So these are the references I have used. So if you have any queries, you may ask now.
So thank you, sir. Thank you so much, sir.
Thank you,
I
sir.
think no queries.
No queries. Okay.
Yes,
Thank you,
sir.
sir. Thank you all. Thank you so much for your wonderful opportunity. Thank you.
Yes, sir. This is session with a practical simulation also, sir.
Thank
Yeah,
you,
sir. You
sir.
can
Your
use any project.
participation.
Sir, one question from chat box.
Yeah, yeah, that is what I am answering.
Yes.
Sorry, ma. Sir, you can use Python also. Suppose if you are using Raspberry Pi programming, then you can use Python code. Or MicroPython, it will support. The ESP device itself, you can use MicroPython. So by using that, we can code anything, sir, like anything. Python programming package. So, for example, this is what, sir, Adafruit. I told you right initially, home automation using ESP, sorry. Okay, ESP SQL search. I can go with the randomness. So this is the best website I told you, right, sir? So you can go to this.
Thank you, sir. Thank you so much, sir.
So wait a minute. Only one. Yeah. Here you can find, sir, all the MicroPython libraries and the procedures, step-by-step procedure, and then the screenshot. Everything will be available here. So
Yes,
this
sir.
website, sir.
Yes.
I'll be pasting in the chat box. Here you can find everything, sir. Thank you. I think I have answered, sir. Welcome, sir. Yes, sir, I have done it. Thank you.
Thank you, sir. Ritika Sri.
Yes, sir. Thank you, sir. Your participation has added immense value to our event and inspired us all. Your insightful remarks and thoughtful addresses have left a lasting impact on everyone here. We deeply appreciate the time and effort you took to be with us and share your wisdom. Thank you once again for your support and for honoring us with your presence. We look forward to future opportunity to collaborate and learn from you, sir. Thank you, sir.
Thank you, sir. Professor, shall I leave?
Sir.
May I leave, sir?
Yes, sir. Thank you,
Yes,
sir. Thank you so much, sir.
Thank you all.
Thank you. So thank you all participants. Thank you so much. So we meet on 16/8/24. So tomorrow we don't have session. Tomorrow is Independence Day. So we have session on 16/8/24. Thank you. Thank you all. Thank you, everyone.